You might already be familiar with some of the elements of the periodic table. We breathe oxygen. We use helium to blow up balloons. We make gold and silver into jewelry. We use copper for wire and silicon for computer chips. But maybe you're not as familiar with element number 39. Named for the Swedish village where it was discovered, yttrium plays a surprisingly important role in our everyday lives, even though it isn't quite as famous as some of its siblings. But where does it come from, and what do we use it for? When the universe was formed in the Big Bang, the only elements around were hydrogen and helium. These gases condensed into stars, which get their energy by smashing elements together to make heavier and heavier elements, all the way up to iron, and a process known as fusion. Some of these elements aren't stable and decay into other elements. Yttrium's one stable form is the result of the decay of the element strontium. A small amount of yttrium is formed in the explosions of dying stars hundreds of times larger than the Earth's sun. However, most yttrium is formed in smaller stars near the end of their lifespan via slow neutron capture. Sometime later after the Big Bang, all of the interstellar debris began to collect and rotate, which flattened it into a disk. The center of this disk later became a star, our sun. In the outer regions, gases began to condense together, eventually becoming the planets we know today. Earth is one of the 4 inner rocky planets in our solar system. It has 3 main layers. The center, or the core, was formed as heavier elements like iron sunk to the center. The mantle consists of lighter elements not present in the core. As parts of the mantle melt due to the Earth's heat, they rise to the surface and eventually become Earth's crust as they cool. Minerals are made up of grid-like structures of different elements that atoms can slot themselves into. When the mantle melts, some of the elements are pushed out into magma because they don't fit into the crystal structures of the minerals that make up most of the mantle. These incompatible elements will be much more prevalent in the crust than in the mantle. Yttrium fits very nicely into the minerals in the mantle, so it's distributed evenly throughout Earth's outer 2 layers. Yttrium is primarily mined from a mineral named bastnäsite, which is made up of fluorine, carbon, and oxygen. Yttrium is also found in monazite and xenotime, which are mostly made from phosphorus and oxygen. All of these minerals are abundant in many other rare earth elements. Most of these rare earth deposits are located in China, which supplies the majority of our yttrium. One of the biggest deposits is the Bayan Obo mine. It formed about 1.5 billion years ago. That's almost 1/3 of Earth's age. Yttrium isn't found as a pure metal in the Earth's crust, though. Instead, it is found in mineral ores. These are mined using open pits that can be over a mile wide and hundreds of feet deep. However, most ores don't have very much of these minerals, so they must be ground down into a powder and concentrated. Separation processes can use density, electricity, and even magnets to concentrate the elements of interest. Yttrium is extracted from the mineral powder by treating it with an extremely strong acid at a very high temperature. The dissolved yttrium is then mixed with another liquid in which it dissolves more easily. This solution can then be allowed to crystallize or run through more procedures to achieve an even higher purity. Once isolated in its metal form, yttrium is used to make the LEDs in your phone's screen. Yttrium has a special property known as phosphorescence. This means it emits light at a higher, redder wavelength after being lit up by a lower, bluer wavelength. It can be used to create white light by converting some of this high-energy blue light from an LED into a lower-energy yellow light. Not only does this allow for white lights in displays, the white lights made by yttrium look much more natural and like sunlight than other types of LEDs. Yttrium can also be used on its own to create a very vibrant red light. But all of this doesn't come without a cost. The process of carving pit mines out of Earth's surface results in destruction of entire ecosystems, and is one of the main causes of deforestation in several countries. As mining continues, millions of tons of rock waste are produced every day. This also produces lots of dust that can make it harder for people to breathe, in addition to decreasing air quality. The process of refining yttrium produces a contaminated water known as slurry that's highly toxic due to how many heavy metals are contained within it. The refining process also uses extremely strong acid that presents a massive risk to everyone who handles it, because it is so corrosive and can cause severe burns. Unfortunately, like most rare earth elements, yttrium is rarely recycled. In fact, less than 1% of rare earth elements used today are recycled. One of the main reasons for this is that it's often cheaper to just buy new yttrium, even though this completely ignores the environmental costs of mining. Another reason is that it can be very difficult to separate electronic waste into its components, and even more complex to separate the rare earth elements because of how chemically similar they are. This means we have to take care to use the yttrium we do have wisely. There's still hope, though. Researchers are working on ways to recover yttrium using everything from special solvents to UV lights, so that we can continue to minimize our impact on the Earth. After its long journey from the center of a collapsing star to a swirling cloud of interstellar dust, to the inside of the Earth, to an ore deposit, to the processing plant, yttrium finally makes its way into LEDs, just like the ones in the screen you use to watch this video.